All right. Welcome back to another exhilarating Algebra 2 lesson. We're skipping for 3 just because it involves a lot of graphing by hand, and well, not all of you have graph papers. So we'll just skip that one and move into 4.4, which is on matrix determinants, and then Cramer's rule, which we'll be using to solve some systems of equations. But let's just start about talking about determinants. So the determinant of a square matrix, so again, that's the same number of rows as there is columns, is the difference, meaning subtraction, of the products, meaning multiplication, of the main diagonal and the other diagonal, respectively. So what's happening when we take the determinant of a 2 by 2 matrix is we're multiplying our diagonals, so 1 times negative 4, and 2 times negative 3, so that's in blue and red here. And we're taking the difference. So we end up with negative 4 minus a negative 6. So the determinant of this matrix would be 2. 3 by 3 matrix get a little bit trickier, but overall it's the same exact concept. The first thing you're going to have to do in a 3 by 3 is copy over the first column. So if you look, I copied this one over here, and the second column over here. And you'll see why we're doing that in a second. So first step, copy the first 2 columns over on this right side. Then what's going to happen is we're going to calculate products just like we did before. So we're going to calculate these blue products going that way from top left to bottom right. Find the sum. Do the same thing with these other diagonals. And we're going to take that sum and then find the difference. The reason we have to add these other 2 columns over is so if you look at just this box here, well, we're not going to include all the values. See, this one's missing. So we got to move over to make sure we cover all the values in that matrix. So here's our 3 by 3. Let's try to keep the same colors as over there if we can. So I'm going to go down here. We'll switch to some bluish color. All right, so let's rewrite our terms. So actually, let's use this color for that. All right, so we're going to rewrite 0, 4, 2. I'm going to try not to be sloppy here, but no promises. And 0.5. So I just copied over these first 2 columns. All right, then I'm going to start taking my diagonals. So this one, multiply those. 0 times 1 times 3. Well, that's 0 plus negative 5 times 6 times 2. So that would be negative 60 plus negative 1, times 4 times 0. So 0. Now I got to do the reds, and this is all going to be subtraction. So for the reds, I have 2 times negative 1 times 1, so that would be negative 2. 0, 6, and 0.5, well, that's 0. And then 3, 4, negative 5, that's going to be negative 60. So now, what I end up doing is I take this sum up here on the top, that's negative 60, and then it's minus this sum down here, which is a negative 62. So the 2 negatives become a positive. Our determinant is 2. So that's the process for a 3 by 3. So going back to the 2 by 2s to make sure you remember, it's the main diagonal minus the other diagonal. So here we would have 3 times 4, which is 12, minus 3 times negative 2, which is negative 6. That would be 18. Next one, main diagonal, 1.2 times negative 3. It's going to be negative 3.6 minus 12 times 0.5, which is 6. So that would give us a negative 9.6. And then finally down here, main diagonal 1/2 times 4, and that would be 2, minus Negative 2/3 times negative 1, that's going to be a positive 2/3. So that would get you 4/3 because the 2 is technically 6/3, right? So 4/3 is that determinant there. All right, now we're going to be using these determinants to solve systems. Remember, systems when you have more than one variable, right? So we got to solve for x and y. You're also going to have two equations when you have two variables. So here's the problem right here. We got 2x plus y equals 10, 3x minus 2y equals 8. We want to solve for x and y. Well, first we need to write down our coefficient matrix. So again, coefficients are just the numbers in front of the variables. So we have 2, 1 for 1y here, and then 3 and negative 2 for the bottom. So first step is to calculate that determinant of that matrix. So that's negative 4 minus 3, so we get negative 7. Then we go to the next one. So here we're solving for x. So what happens is we take our constants here, the 10 and the 8, because we haven't used them in our coefficient matrix. When we want to solve for x, we're going to take the 10 and the 8, and we're going to replace them for the x values. So the 2, 3 get replaced by the 10 and the 8. And then we calculate that determinant. So negative 20 minus 8, that's negative 28. And we're going to divide it by that original determinant. So divided by negative 7, we get 4. Then if we want to solve for y's, we take the same two equations that we had. And again, we're going to take the constants, but now we're going to plug them in for the y values. Okay, so we're plugging them in here. So it's like you have an x column and a y column. And then you repeat the process. 16 minus 30 is negative 14. And again, we divide by that original determinant of negative 7 to get 2. So our solution here is 4, 2. Feel free to rewind that and look at it again if you need to. We are going to have infinite no solutions. So obviously, we know we can't be dividing by 0, right? So that's kind of what this kind of all comes to. So when the determinant of the coefficient matrix, so again, that was the first one, this one here, when that is 0, so this denominator is 0, you're either going to have infinite or no solutions. So here's the difference. If it's infinite, at least one numerator determinant is 0. So that means at least one of the top ones is 0. Because we can do 0 divided by 0, that's fine. Now, when it's no solution, neither of your numerators are going to be 0. Okay, so if neither of them are 0, it's no solution. If at least one of them is a 0, then you're good. Then we say that's infinite solutions there. So let's practice a couple more here. So to solve this one, we write our coefficient matrix. So that's 2, negative 1. Now notice they're out of order here. You want to go x's then y's. So this would be 4, 1. So this is your coefficient matrix. So that determinant is going to equal 2 minus negative 4. So that determinant is 6. So that's going to be our denominator. All right, then we got to go through and replace. So for the first one, we need to replace the x's with 1 and 11. So we go 1, 11. We leave the y's alone. And that determinant is going to equal 1 minus, I'll write it out here, negative 11, which is 12. So then we take it and we divide it by the 6. So x is going to be 2. Then, I suppose I didn't leave myself enough room, so I'm going to try to cram it in over here. We take the 1 and the 11, and we're going to replace it in the second 2. So I'm solving for y now. So I leave the 2, 4 for my coefficient matrix, and I'm going to go 1 and 11 here. So here we're going to have 22 minus 4, so that's 18, divided by 6 equals 3. So our solution is 2, 3. All right, down here, let's do all this the same color now. So down here, again, we want to have everything in order. So let's switch it to 3x minus 2y equals negative 5. down here. And you can do this a little bit, differently depending on how you want to. I'm going to move the 9x over to the left. So it would give me a positive 9x. I have my negative 6y here. And if I move the 15 over, that gives me negative 15. So my coefficient matrix for this one is going to be 3, negative 2, 9, negative 6. So this determinant, I would get negative 18 minus a negative 18. So here we get an answer of 0. So when that first determinant is 0, you should already be thinking, all right, it's going to be either no solution or infinite solution. So let's find out. So again, we're going back to this coefficient matrix. If we replace the 3 and the 9.
Missy Walters, please call the office. 3500, thank you.
Apparently Missy Walters needs to call the office. So we replace 3 and the 9 with the negative 5. Negative 5 and negative 15. Leave the negative 2 and the negative 6 alone. Calculate that determinant. So let's see, we got negative, or actually, should say positive 30 minus a positive 30, and that equals 0. So if you get any 0 over zeros, it is going to be infinite solutions. All right. We're going to try to do a 3 by 3 here. Let's first talk about the problem. All right, so it says Dale and Brennan are at the candy store. Dale buys 2 pounds of Skittles, 1.5 pounds of Starburst, 3 pounds of gummy worms for a total of $28.42. So we got 3 variables at work here. So we're going to have...
Sean Hollinsworth, please come to the office. Sean Hollinsworth to the office. Thank you.
So 2x, x will be Skittles, plus 1.5y for Starburst, plus 3, we'll say z for gummy worms. That equals $28.42. Then, for the other one, Brennan's 4.5 pounds of Starburst, so he didn't have any Skittles. So it's just going to be 4.5y plus 2 pounds of gummy worms, so 2z, for a total of $39.39. And then it says the price per pound of Starburst, so that was y, equals, lost my spot, equal to the per pound of Skittles plus the price per pound, so I forgot price up there, of gummy worms, so x plus z. Well, we want that to be in standard form, so we're going to change that to x minus y plus z equals 0. I just subtracted the y over and then kind of flipped it around. So these are 3 equations. So coefficient matrix. And this is going to be a 3 by 3. So we got 2, 1.5, 3, 0, because there's no x, 4.5, 2, and then we got 1, negative 1, 1. So this is going to be our coefficient matrix. So we're going to have to calculate the determinant of this. We could do it by hand, but it's going to take a while. If you want to do it by hand, be my guest. But we're actually going to use a calculator to do this, and I'll show you how to do it. If you check this message on Canvas, there should also be a link to download this calculator. So it's basically just a graphing calculator you can pull up on your computer. Be really handy for this stuff. Fortunately, these videos only let me go to 15 minutes. So right now I'm just going to end this first video, and I'm going to add another video showing you how to do a 3 by 3 matrix. So there'll be 2 videos for this one. And then I'll be giving you the assignment 2, which is actually going to be on Delta Math. So I'm going to close this video and quick start a new one so I can show you how to do a 3 by 3 Cramer's rule on a calculator.